Today, our topic is circular economy, risks, harmful substances, and awareness, a little bit of the end of waste legislation. My background is in my background is technology. I've been teaching circular economy, waste management, recycling topics for several years already at Sykli since 2016, and before that I was several years working at the Aalto University. And I have also been working within waste management companies, so this is hence a strong background in waste management and recycling issues. In addition, I'm a vocational teacher from Haga-Helia. And today our topics are, as I said, recycled products and end of waste legislation. They're actually recycled materials, more likely. And then I think a big issue that is not always taken into account, which is risks posed by circular economy. And also something about harmful substances, not only hazardous materials, but other viewpoints to it. Well, first to end of waste legislation. Basically, material is defined as waste. It should then also be treated as waste. And then, of course, if we want it to cease being waste, we need to take into account that we already have defined the material as waste. And it's not always quite simple to start using it as product or secondary raw material. So we need to specify and make some bigger changes there. This kind of end of waste criteria is specified in the Waste Framework Directive, and here, of course, it is important to understand that once we have defined that a substance or material or object is waste, it is not necessarily always possible to use it as a raw material. And it's not only because of the legislation, but we need to be certain that it's safe to use, and there, of course, there needs to be a market, because otherwise, or demand for this kind of material or objects. Otherwise, it's not very sensible to shift a product or material from being waste to being actual a recyclable material or usable raw material. And it, of course, needs to fulfill certain technical requirements and other existing legislation concerning how safe it is to use, that it doesn't contain too many or at all hazardous substances, or at least in such a form that they could cause health or environmental impacts. And that is actually the most important issue concerning this end of waste criteria. We want to use materials in a safe way and manner. For some materials, already certain end-of-waste criteria have been set, and for example, several metal products or material streams such as iron and steel and aluminium scrap, as well as copper scrap, and also glass cullet. And I think for possibly for further materials, this kind of legislation will be set in future, but is not yet in force. Also, the Waste Framework Directive defines byproducts or as a substance or object resulting from a production process, and that the primary aim is not the production of that specific material or item. And this can, of course, byproducts can be produced in any sector, really. So that's there are many possibilities here. Okay, we have different risk factors when we are talking about work environment, and also in specific circular economy today. And many of these we are very aware of chemical risk factors or certain biological risk factors, especially now that we have been experiencing a pandemic for the past 2 years. So we are very aware of certain biological risks. But I think to circular economy, this amount of risks is very much more diverse due to us using recyclable materials or waste materials for our products, or reusing materials. And it is very important to be aware of the material or substance content and hazardous materials content of these material flows and products, so that we can treat them in a safe and good manner. And of course, in any occupation, we have several different kinds of occupational hazards. Maybe if we're just working in an office, it might just be cleaning chemicals, or I don't know, maybe noise or odors or something like that. But of course, when we are working with manufacturing processes or recycling processes or waste treatment processes, there are multiple different materials and substances that we need to be aware of and take into account. Well, of course, maybe chemical and biological exposures are most common cause, actually, most of the occupational diseases, at least in Finland. And actually, if we're looking at circular economy and in specific the waste management sector, these kind of chemical risks have actually raised concerns, and many risk assessments have been made. But I think there's still a huge need for further information, and we need to better our collaboration to ensure safe work environments. And I think one way is also to try to not necessarily to replace people doing the jobs, but replace people from that kind of tasks where the exposure to hazardous materials is large. And also, of course, if we're looking at circular economy, we don't always know the material composition, and an extra problem there is caused by import and export of these waste materials and recyclables, and we can also be exposed to unknown microbes and bacteria and also unknown materials. Well, if we look at risks at work, they can basically be divided, I think, into three categories: physical, chemical, or biological risks. And well, if we look at chemical or biological, it's maybe something that comes into contact with a human, maybe through the skin, or probably is breathed, or that means through inhalation. But it can also be caused by physical things like noise in the environment, or cold work environment, or hot work environment, or something like that. And of course, everything doesn't cause occupational diseases. There are maybe less hazardous forms of occupational exposure, such as temporary symptoms that cause temporary symptoms like skin irritation, or maybe nasal bleeding or headaches or things like that. But if they are ongoing, they can be categorized as occupational diseases, and we have all kinds of different categories of occupational diseases, like allergies or asthma, or even cancer or nervous system diseases in really bad cases, and mostly from long-term exposure, but depending on how big a risk the material or substances that we have been exposed to, also short-term exposure may be a problem. Okay, if we look at chemical and biological risks, are maybe the most common ones, and there we can also divide it into two different categories. It can be caused by the job itself. For example, textile dust, or something like that, when treating textiles, or something like that. Or it can be due to something unrelated to the actual work itself. I think the one good example is in Finland. Many teachers and probably many pupils at schools get problems due to indoor air quality because of mold in old schools, and a lot of old schools have been demolished, and new schools have been built due to this problem. And I think many teachers and students are still being exposed to molds and microbes and materials, substances in air due to mold. and this, of course, has nothing at all to do with the teaching itself, but is due to the building where the teaching is happening. Some of these can be less harmful. They can cause allergies or just irritation, but some can also be toxic or carcinogenic. And it's not always only what material we are exposed to. It can also be due to the concentration or the amount of exposure or duration of exposure. And then also, I think it can be there can be personal differences between different people, how easily we are affected by different substances. For example, again, mold in buildings. I think, of course, everyone is in the building will be in the moldy school will be breathing the moldy air in that building, but not everybody gets disease by it. Everybody doesn't get allergies or even though we are, or even though everybody is exposed to the same risks. Typical biological exposures are, of course, bacteria, fungi such as yeasts or molds, different kinds of viruses, parasites, and prions. Most of these are actually odorless or invisible, but it's not always very easy to detect these dangers in advance. And I think one thing that totally surprised us all was the intensity of the COVID-19 and how it spread worldwide to become a worldwide pandemic. And also precautions due to this were quite extensive. We didn't know in the beginning how easily the virus, how easily it spread, and how big cautions we really needed to take. At least in Finland, I think that everybody pressed the pause button in March 2020, and we avoided going anywhere and meeting anybody. And in many ways, maybe it was a good precaution, but all precautions were not maybe necessary. There are different ways we can be exposed to this kind of biological risks. It can be, I think the most common version is drop infection or aerosol through breathing, and but some biological risks can also spread through skin contact, for example, or then orally by eating something not that shouldn't be eaten. And of course also animal bites or insect bites. I think we are all in Finland at least very aware of ticks and the diseases that they can spread. Biological exposure or causes different symptoms depending on, of course, what kind of exposure it is. If it's through a respiratory irritation, I can call different allergic symptoms, asthma, runny nose, basically, or then also skin diseases. And of course, depending on if it's something that we have ingested, then it can also be something like nausea or diarrhea. So we have very many different kinds of symptoms for this kind of exposure. And of course, many of these symptoms can be something else as well as the biological exposure. But I think biological exposure is very common. And if we now think about circular economy again, we are working with recyclable materials and waste materials, and we don't know how clean or pure our products are always. And maybe sometimes we do, but it is very difficult to be aware of all different materials or bacteria or virus that can be spread through these kinds of materials. Okay, we have different kinds of agents in the work environment, and I think one very common one is different kinds of dusts, whether it's food dusts like flour in a bakery, for example, or textile dust from treating textiles. Of course, textiles can cause problems in both the recycling industry and circular economy in that way, as well as in the production of using new raw materials, virgin raw materials. And of course, wood dust if we are working with forest products and wood. And for example, I have here as an example also ticks. They are in Finnish punkki, which spread diseases. And well, in Finland we don't have very many insects that spread diseases, but elsewhere in the world there are other insects as well that spread diseases, and this is of course something that we need to be aware of, and also aware of when we are treating waste materials or recyclable materials from that have been imported or exported. And then we have other infectious diseases or zoonosis. With zoonosis, we mean diseases that are contaminated from an animal to a human being. and I think that was at least one of our one of the theories behind COVID-19, but I'm not sure if it's the entire truth. Bats and COVID-19. And of course, any kind of infectious diseases can be spread through waste materials, and maybe HIV is not the most common one, but at least when we are treating waste materials, bio waste flows, waste wastewater. The people working in these environments are exposed to a multiple amount of different diseases, and need to be cautious in their work environment due to this. Of course, if we are exposed by biological different kinds of biological risks in the work environment, and there are different ways of preventing, or at least being cautious, and we can make different occupational hygiene measurements or biomonitoring, and also use protective clothing or other protective wear. And of course, vaccinations, and for many people who work within risk within a work environment where different risks or specific risks have been recognized, will be automatically vaccinated against these specific diseases when there is a vaccination for everything. We don't have vaccinations. And of course, there are very many reasons and typical causes for occupational diseases within waste and wastewater management. And of course, one cause is that the waste, we don't always know exactly what it consists of. There may be other materials, even if it is sorted at source. It might not always be sorted correctly. There are many unknown variables also in recyclable materials, and also in wastewater. And mostly, I think one thing that is typical for waste and wastewater treatment processes is that it's fairly easy, or at least possible, to be aware of and measure and monitor substances and materials that we are aware of that exist in these material flows. But it can be very, very difficult, or practically impossible, to monitor something that we are not even aware of. And this is, of course, one problem and risk in circular economy specifically. Here we have examples of typical biological exposure in Finnish workplaces. Of course, the food dust, and depending on what kind of workplace we have, it can be animal dandruff, for example, in farms or in farm environment or something like that. I think molds and compounds caused by molds are can be a risk in almost any work, especially if it's um, has more to do with the building itself than the work tasks. But of course, molds are present also in recyclable materials, and this way it's clear risk also when working with circular economy. Bacteria and viruses, I think the most obvious is if we're talking about bio-waste and wastewater streams, but also other materials have cause risks with bacteria and viruses, and often the more humidity there is in the material, the better the bacteria and viruses and mold and this kind of risks are present. And then also latex can be a problem. Well, if we look at a bio-waste treatment plant or process, of course, already the bio-waste collection and transport and storing cause problems, and at least odors and vermin, and of course the storing is, if it takes a long time, we can also have molds and bacteria and viruses and so on in our bio-waste. And at the very least, then once it gets to the treatment process, there can also be odors, and vermin can cause problems. Maybe it's more about the storing than the actual treatment process. And then, of course, in different parts of the process, there can also be unwanted gases produced, sulfur-rich gases that can be very are both health nuisance and odorous. Carbon monoxide, methane. Of course, if we are treating our bio-waste through anaerobically, then we want methane to be produced. But of course, when it's controlled and the methane is collected, it is fine. But if it's produced in the wrong kind of environment, it can cause and will cause problems. And of course, when we are talking about bio-waste, and bio-waste is very wet, and there are it can cause leachates and other waters which are very nutrient rich. So of course, this kind of nutrient rich water doesn't need to be a huge problem if it is used for the right purposes, but in the wrong place, the nutrient rich waters are a problem. So we don't want them into our natural waters. And then, of course, molds and bacteria and viruses and so on. It is also very common with exposure to physical hazards in the work environment, and this there are actually many different work environments where this is typical. I think I have a comment in the chat. Oh, I don't know if there's. Here's the question: is there some regular certified biological contamination checking of, for example, university facilities, and how they are done, if exist? I think these are things that if it is, I don't think it's done regularly, but of course, if it is probable that there is some kind of biological contamination, for example, there's suspicions of mold, for example, then there will be checking of the facilities, and I think many of these are also dependent on what actually is of course discussed with these things are discussed with the experts, both medical experts and experts concerning specific substances, for example, and then of course the need for some kind of checking can be evaluated. So I don't know if I answered the question well enough, but I don't think it's automatically that anything is checked. Yes, it's very difficult to check contaminants regularly, and so there needs to be some kind of suspicion that or knowledge of some contaminant being present. And of course, we have, if we look at physical hazards in the work environment, they are, they are the ones that are not chemical and not biological. So anything that noise or cold or heat or vibration or different, for example, ultraviolet light or UV light or electromagnetic fields can also be physical hazards. And of course, why are they physical hazards? Of course, because they cause discomfort and in the working environment. And I know that I can't remember the temperature guidelines for a working environment, but if it is too hot, I think there's at least in Finland guidelines for having breaks often enough. So I think if it's a very hot summer day, then we are obliged to have breaks more often than we would if without the heat. And the same, of course, if in a very cold environment. But of course, cold and a cold environment is maybe easier to tackle through appropriate clothing, but of course not to any given level. And also a work environment that is always very hot is there's also a specific defined how often and how long breaks need to be taken. This can be in a industry where the production process, for example, generates heat and makes the working environment very warm. Noise is a very common physical exposure and actually causes the most occupational diseases in Finland. And also noise is something that increases risk of accidents, because maybe the noise or the background noise shuts out some other noise that we would need to hear to avoid accidents effectively. Of course, we also should be wearing protection for our ears for the noise. And I think, of course, here we think of the noisy environment will probably be some kind of production process or recycling process or treatment process. But if we look at it more broadly, I think school classes can be very noisy as well. So maybe teachers also risk of this kind of noise exposure. Okay. Then, of course, different kinds of occupational hygiene measurements can be done, and there are limit values and guidelines. Also, for example, for noise, there is risk. There are certain decibel amounts that are recognized as a bigger risk. So this is also important to be aware of. It's not only in the work environment. It can be enough to go on a rock concert. So I think many musicians should be aware of the noise, even if the noise is enjoyable. Now we will continue with the chemical hazards, and that's quite many complicated matter. There are many different kinds of chemicals, and they have different hazardous different ways they are hazardous, and we of course need to identify the hazardous materials. And actually, this is obligated by the employer to the employer is obligated to know what chemicals are being used in the company. And of course, depending on what kind of company we are talking about, there can be very few chemicals, maybe just some cleaning chemicals or something like that, and or there can be a wide variety of chemicals if chemicals are used in production processes or such. And of course, as well as to identify the chemicals and the hazards associated to them, also assess the risks involved. And this, of course, takes us to the third point, that the employer needs to take the necessary measures to manage these risks that are known due to the chemicals that are being used at the workplace. At every workplace, we should have an up-to-date safety data sheet that where we know we should have also an inventory of chemicals. It should be always up to date and available to the employees, that they know where and how the chemicals are being stored, in what spaces there are of each specific chemical, and of course also to know how to what to do if there is an accident, if we have some have been exposed to some chemical that should be avoided. This way, all kinds of occupational risks should be assessed, and actually all chemicals in the EU are classified under this kind of regulation. So then we come to the waste management streams, and here we obviously also have chemicals, and once they are in the waste management stream, we're maybe talking about hazardous wastes. And it's very important that we know and recognize and can assess what materials we have in our material stream, to be able to take the right precautions and to be able to treat and maybe separate these specific problematic materials or substances. But one problem is, of course, that we don't always know what the recycled material contains, or the recycled material stream, or the waste material stream. And it can be very difficult to treat unknown substances. And especially within waste management, when we're taking, of course, companies should be very aware of what materials they have and what hazardous substances they possess, and as well as what hazardous wastes they produce, and which are being in the material streams. But then when we are talking about households and waste generated in households, everybody isn't quite as aware of the materials in their waste, and especially if it's something that is found years later, maybe in the garage, or maybe after death or something like that. The cleaning and of the household, or emptying of the household, can cause problems if we don't know what all the materials and all the wastes are, and if what kind of hazardous wastes there are. So something about hazardous substances and hazards in all. Of course, we saw actually on the previous sheet, we had all different kinds of signs showing that they are that we are dealing with a hazardous substance. And I hope actually everyone should be aware of these signs and what they mean, and also how to handle substances with this kind of properties, which actually should be, I think, quite important, especially in areas of work where typically these kind of substances are being used. More specifically about these signs, these modern signs came a few years ago already. Old version of these were on an orange background. Maybe some of you remember, and if you have very old materials or paints or something like that at home, hopefully not in the workplace, but sometimes in households, there may be some older chemicals. They might have the older signs on an orange background. But there are actually two main signs that indicate that we are dealing with material that poses risks on health. And one is this symbol with an exclamation mark. It tells us that it has some kind of toxic properties. It can be through orally or inhalation or skin irritation or eye irritation or something like that. And this kind of sign tells us that we need to be cautious when we are handling this kind of materials. Another one that tells risks on health is the health hazard sign. It actually, I think it shows, looks like the lungs are exploding of the person in the sign, and it tells us that it is a health hazard. There are different hazardous categories. It can be cause cells to mutagenize, or it can cause cancer, or have other toxic properties. Then some of the others, for example, corrosive or acute toxicity. Well, once you have inhalated something like this, you probably won't need to know what it contains anymore, since it is acutely toxic. So great caution should be taken. It's not only it's a huge health risk. But very common can be this sign where that is corrosive. It can cause corrosive to metals or other hard substances, and of course also to skin if we get into contact with it. So this way should be aware of these kind of health problems. Then the explosive or flammable properties tell us that the explosive is a picture of an exploding bomb, and of course any explosives should be handled with caution. But many chemicals, for example, organic peroxides, can also be explosive. And then we have flammable materials with a flame sign, and there are many substances that can be flammable in themselves, flammable gases or liquids, and different kinds of self-heating substances or mixtures. And then we have the oxidizing, which also says that the flame is over a circle. It can also cause flames or as it is something that causes oxidizing reactions with oxygen. And gases under pressure, for example, different kinds of. We have a gas cylinder here, for example, bottle of hairspray, and I say for these oxidizing and exploding and explosive and flammable materials are maybe the most common combinations of these are ones when something is sorted wrong at source, and then it will probably, it's one of the most common causes for fires in waste truck, for example, or at waste treatment or recycling plants, that we have something, for example, gas bottle under pressure that gets pressed together with something that is easily flammable or something like that. And then we have, of course, substances and materials that are hazardous to the environment, and can, I think, if we are looking at recycling and waste processes, the ones that we tend to attend to the most concerning occupational health risks and overall risks are the ones concerning the health and ones causing risks on the environment. And of course, risks like fires or something like that are also need to be taken into account, but are maybe not observed quite as much from the health perspective. Well, there are very many different workplaces that expose people to chemicals, and very many of these are somehow to do with recycling, circular economy, waste treatment, for example, demolition of buildings. We have a very multiple amount of different materials in old buildings. Or also treatment of waste electrical and electronic equipment or end-of-life vehicles have a wide range of hazardous materials, and which need to be taken into account in the treatment processes. And this is, of course, concerning waste electrical and electronic equipment, for example. It is a problem when we know about the illegal streams going to third world countries, and we know that the treatment processes there for these products is not appropriate, and this can be a huge problem. Well, then, of course, any sorting or storing of recyclables and waste materials, plastics, textiles, metal scrap, glass, anything exposes us to or the work this kind of work environment exposes to different kinds of chemicals. Metals recovery processes, also those that are not recyclables, but from ore, also cause hazard. And then if we're talking about waste, of course, if we have landfilling of waste, there is such a wide range of different materials, and maybe it doesn't necessarily seem as it does much in the landfill, but I'm sure that many of us still in Finland still remember housing area that needed to be demolished in Myllypuro in Finland. That was some 20 years ago, that had been built on an old landfill, and the contaminants and hazardous substances and the landfill gases caused health hazards and symptoms in those living there, as well as there being problems with the stability of the buildings. So in the end, they were all demolished, and the contaminated soils, I mean the old landfill materials, was treated appropriately, and nothing was built. No housing was built on that area again. But also waste incineration plants, we have a lot of different materials, especially in mixed waste. There can be also hazardous materials in mixed waste, as everybody doesn't sort everything perfectly. And because of the wide variety of different materials in the waste incineration plants, the cleaning of the flue gases needs to be very carefully done and properly treated, because otherwise the environmental impact and the health impact of these flue gases will be a problem. Of course, any part of waste collection and transport processes can cause problems, not only because of misplaced waste or wrongly sorted waste, but also due to the different chemical or biological exposures. And then also ash treatment, especially if we're talking again about waste incineration plants, the fly ashes can be very toxic and have hazardous, a wide range of hazardous compounds, heavy metals, and so on. And also the bottom ashes, we need to be aware of that. The ash can also contain hazardous materials. And then, of course, any plastic treatment processes can also generate hazardous fumes, and this way also coating processes or 3D printing. Well, for example, I talked earlier already a little bit about waste electrical and electronic equipment treatment processes, and here occupational hygiene measurements need to be made, and also the process need to be planned in a way that the occupational hazards are as small and little as possible. But especially if we are talking about crushing this kind of equipment, there are multiple different materials in these, and then there can be the dust created in these kind of processes, and of course we get a lot of recyclables, but the waste fractions produced during the treatment processes have a hazardous content due to hazardous substances, especially problematic and heavy metal content, for example. Also, one problem is brominated flame retardants and other partly banned substances in the e-waste treatment processes. And even though many of the most hazardous materials have been banned from products already several years ago, the material flows of e-waste to the treatment processes are not necessarily the equipment we bought last year or this year, but they can be 20-year-old or older. So the waste management sector, at least concerning e-waste, will still, years to come, treat materials that have high contents of already banned or restricted substances. So in the recycling business, this is a problem. Well, we've talked about chemicals in circular economy and the presence of hazardous substances, and of course many of these have been restricted, and actually the very old telephone in the right top corner, I don't even know what materials it contains. I haven't made that study, but if we look at an IT product from the 90s and compare it to an IT product from today, the one from the 90s or the 80s had only a little over 10 materials. maybe 15 or 16. And the item today has over 60 materials. And well, the size hasn't significantly changed, which means that the concentrations of different materials are very much smaller for many materials today, and can be more difficult to remove from the material flows, and to actually separate during the recycling process. Of course, what kind of concentrations we have of different materials affect how easily they can be treated and separated in the treatment processes. Also, what kind of properties the materials have, and what kind of combinations of different materials we have in a specific product. And of course, many treatment processes also need chemicals to separate in the treatment process for the treatment process to function. And of course, if we know what chemicals we have and what materials we have in which component, it makes our treatment processes easier and separating the different materials. But for all products, we don't even know the exact material composition. And especially if we in the same waste stream have products that are 30 or 40 years old, as well as ones from today, the material composition can be very different in these time travel products. Well, of course, we should be able to follow the product information and know the material composition of a product and the possible treatment methods throughout the entire life cycle. And I think the legislation is going towards this kind of this way of informing about products and materials. But of course, here we still see the problem that we have in waste management, that we will have products that have come into the waste stream earlier and causes different kinds of problems. Well, ideally, we would be able to separate all materials in the material flows, and at the very least separate the hazardous substances in these flows, and both identify and be able to remove them from the material flows. And this way be able to better manage the environmental and health risks when using waste-derived materials. More and more substituting materials or less harmful chemicals are being developed, and I think this is a very good development, but of course, depending on what kind of materials we are looking at or what kind of products we are looking at, the time span before it ends up in the waste stream might be quite long. And well, for different products, it's different. If we are talking about food packaging, then they will probably enter the waste stream very fast. But if we are looking at furniture or e-waste, the time span will be much larger. Well, here are some common chemicals. Asbestos has been a problem a long time. We have the same problem we have with e-waste. It was banned, at least in Finland, in 1994. But we still have people who have been exposed to asbestos previously, previous to that, or then within the waste management as asbestos products made of asbestos and including asbestos are still entering the waste streams. And we have legislation that says that if for certain renovation projects there in Finland, at least, that the asbestos should be that the renovate that the area that we are renovating, the room, should be tested for asbestos, especially for concerning bathrooms or kitchens or other spaces if we have reason to suspect that asbestos might be present. Then we have, of course, any kinds of materials in processes, for example, for metals treatment or many other production processes, also concerning other materials than metals, detergents, for example, waxes, varnishes, solvents, paints, anything. And there's well, of course, heavy metals that can be included in a wide variety of different products, and from many products, many of these heavy metals have been restricted. Exhausts. It's not only carbon dioxide emissions that cause problems, but there may be other problematic products, and many products and materials have been treated and or the composition has been changed due to awareness rising in different areas. Years and years ago, a fuel, for example, contained heavy metals and lead, and it has, I don't know, it was very long time ago that it was, the composition has been changed so that it doesn't anymore. But of course, many processes, in many processes, some hazardous chemicals are being used. Well, nanomaterials is a problem of today. and we're talking about basically same materials as we are handling otherwise, or that we're using for other uses, but they are the particle size is very, very small. It's between 1 and 100 nanometers, which is small. It's 10 to -9. And well, the positive thing and the negative thing with nanomaterials is that it has a large surface area in relation to its weight. It causes problems in waste management, since the materials, nanomaterials, although they are basically the same material as less nanomaterials, as materials with more of the material. It causes that it has different. It reacts in a different way in the processes, and has different characteristics than the original material. And this can be very, very difficult and complicated in waste management and recycling, and also circular economy. These materials are very new. We don't know how they act, and we don't know exactly what kind of impacts there are on health. We don't know if they are a health risk or not, and this is, of course, a problem. And we can be exposed to nanomaterials in different ways. If lungs or cardiovascular system, if it's in contact with the skin, for example, and goes to our inner organs, for example. And these were recently invented, and we don't have enough information of physical or chemical or physiochemical properties. And I think a lot of more research needs to be done in this area. If we are looking at the waste management sector and also circular economy in this way, one problem is, of course, that we can be exposed to basically anything. And this way, the work environment arrangements and safety aspects there need to be really good. Also, the exposure may or will differ from normal use of materials. Actually, for example, heavy metals, if they are used for in places or in products where the heavy metal has some kind of functional use, then it will not be hazardous while it is being used, but it will be hazardous once it enters the waste stream and is being crushed and treated and separated from the other materials. And this causes, of course, that people working within circular economy and especially within the treatment processes need to be, and their companies and their occupational health services need to be aware of the possible risks as well as possible. Yeah, exactly. Waste can consist of anything and everything. And we have all kinds of materials there. We have hazardous materials, we have chemicals, we have heavy metals, different kinds of bioaerosols and so on. And if we don't know what our waste stream or recyclable stream contains, some of the risks might be transferred to the actual products and to the recycled materials. And this is, of course, a problem and needs to be taken into account when recyclable materials are used for the future products. And for example, in medicine or use or medicine packaging or food packaging, this has been acknowledged so that recyclable materials or recyclable plastics, for example, are not used for food packaging, at least not in such a manner that would be directly in contact with the food. And so that possible problematic materials don't dissolve into the food. Well, there needs to be a lot of development, and of course, if we know what we are treating, it's easier to treat the material flow. But then, of course, if there are big changes in the material flow, also the problems can be difficult to avoid, and there may be exposure to hazardous materials. And also new treatment methods are not, well, waste incineration is not a totally new treatment method. Waste has been incinerated worldwide for over a century. But of course, it's been during the past 50 years or so that we have been aware of the toxins in the flue gases and other harmful gases, and this way being more aware of the need to be able to clean the gases. Also, I think recycling trends. Of course, it's a circular economy goal to recycle materials better and to be able to reuse materials better, foremost. But here it's a very good goal, and of course we need to go towards it, but we still need to be aware of possible harmful substances in the different material streams, and adjust the treatment processes to the material streams, and also choose what kind of materials we want to recycle, what is smart to recycle, and what kind of products is appropriate to produce using these recyclable materials. And depending on what kind of material we are treating, the possible hazardous compounds can vary a lot. And for example, if we are using recyclable metals, for example, they can some metals can be separated very purely, but it depends very much on the treatment methods and what we are treating. Well, legislation is well, both good and bad. The environmental aspects have always been very important in waste management, and I think that they are something that should not be forgotten when we are moving stronger towards circular economy. And I think the material safety aspect is very, very important. We shouldn't put blinders on and just recycle everything, but we should take care that we know our material streams. Or also, risk assessment should be done, and we should collect data on our material flows, waste streams, and also the life cycle impacts of products. So how should we eliminate or reduce exposure? Well, here I just said that legislation doesn't account for everything, but legislation is a very good tool. I think many we haven't we can't we are not restricting materials if somebody doesn't say that, hey, this is really bad and you are not allowed to use it. And I think there are many materials that in history we have used for a long time, and until we have found out that it is actually toxic and we mustn't use it. For example, asbestos. We didn't know how bad it was. And of course, here as well, that as long as it's in the use that it was planned to be used for, it's not a problem. But then when we start demolishing and doing the renovation in the household, for example, then it can be a problem. And then if we think of how we are acting with possible hazardous substances that are necessary for our products or processes or are included in the products, it would be good to be able to eliminate exposure as well as possible and to make the work environment as safe as possible. to provide with the protective clothing and so on. And if that is not fully possible, then also the treatment process or production process should be try to plan it in a way that contamination or exposure is not necessary. Well, practical deeds for a better work environment. I think this is also part of legislation, and most companies, at least in Finland, they are very active in observation and reporting things that they see that could be a risk in the work environment, and corrective measures are being done. And also this way assessing danger in the working environment. We should always also think that can we do things better, smarter? Can we avoid unnecessary risks? Are all the necessary protective measures taken into account, and so on? And also not only with the own working team, but also in cooperation with the occupational health service, observation visits could be made or should be made. Well, for the occupational health service to be able to do the research, they need to know the characteristics of the job and also the materials or risks included to be able to assess health risks. And of course, all kinds of proactive and corrective actions will always improve health of the employees at the workplace, and will also this way account for savings in the future. Also, risk assessment, especially if we have new materials, new substances, new processes, new methods, new working methods, we should always do a risk assessment. And of course, the continuous follow-up if we notice that we haven't been able to take everything into account. Well, I have banana peels. I mean, risk to workers and the work itself can be anything. It doesn't have to be the banana peel. It can be something else that causes a risk. And of course, now we talked a lot about nanotechnology and different applications using nanotechnology can cause risks. And then it's very important to be aware of previous methods and materials, and also what risks they have posed. And if we don't have all the information about methods and materials, is this something that that kind of information that could be better available from suppliers, for example. And also, we need to use the services we have from occupational healthcare and also Finnish Institute of Occupational Health if we suspect any risks in our processes or workplace. And still some examples or practical deeds. The more we communicate, the better our communication is, the better we share our information, the smarter we get, and we can also avoid risks better in the workplace. Using best practices and benchmarking, and of course what information we get from reports, and also reporting on information concerning risks. And finally, about occupational health issues, I think it's very important to be active and to care about your own health and also of the health of your co-workers. So be aware, keep your eyes open and ears open, and it will be easier to avoid. Occupational healthcare, we've been talking a little bit about it already, or actually more about the occupational health, not so much about the occupational healthcare, but it's actually steered by legislation in Finland, and the staff at the occupational healthcare, they need to be aware of what kind of exposures are probable in the workplace, and what kind of significance this can have on health. And this is something that needs to be done in cooperation with the company, especially if there are specific materials that that they are aware of and know that they are handling, and specific problems in the treatment streams, or specific materials or material flows, substances in the treatment streams that need to be taken into account also by the occupational health care to be able to assess health issues. This way, work risks can and must be eliminated, or at least minimized. Everything cannot be eliminated, otherwise we wouldn't produce anything, basically. It is possible. Biomonitoring is possible, and it's possible to do occupational hygiene measurements, but these are things that are not done automatically. They are done if it's expected to be probable. We have been talking about waste legislation earlier, and especially about the avoiding waste and reusing and recycling and recovery as energy, and not so much landfilling. But actually, the most important aspects of the waste legislation and goals is to minimize the impact on health and on the environment. But still, I think the main focus is on the environment, and the health issues are not quite to the same extent included in it. And maybe we are not even aware of everything. I'm not sure we are even aware of all environmental impacts of everything we do. But also the occupational health services, they do need as much information as possible about the material streams, about the substances involved, to be able to identify the possible effects on health by specific substances. The most common occupational diseases, the chemical and biological factors are the biggest causes, and I've actually I talked most about them earlier today. And problematic areas are waste management as well as maintenance. And in waste management, I include also or circular economy processes. Also, noise injury affecting hearing is a big problem and a big occupational hazard. Maybe not within circular economy, the biggest one, but I think it is one where maybe in all working environments, the workers are not always as aware or not as well, don't always use the protection that they should. But I think there's also become. I have experienced some kind of attitude shift in attitude during the past, say, 20 or 30 years. I think today it is considered very much more important to use the protective clothing and other protective wear than it was maybe about 30 years ago or so. And it's we are more aware of problems that can occur and of occupational diseases. Allergic reactions are also very common. They are not occupational diseases as such, but of course in repeated reactions can become a big nuisance and a big problem if it's work related. It may be one reason to have to change work. And then, of course, we know that asbestos has been banned for many years already, but still there are people being having reactions to it, or it can be cause cancer and lung disease. Occupational asthma is very common in especially work areas where there's some kind of dust. And a very new one is COVID-19, where in Finland, at least, people who worked within healthcare were diagnosed with it as an occupational disease. So situations change. Well, still about the occupational health care and exposures at work. So do we always recognize all the exposures that could be caused by their raw materials? Do we identify all the substances, or are there a lot of substances that are unidentified? At least in waste streams, this can be the case. And are there special employees in special work tasks that should be monitored, that especially should be monitored at occupational healthcare? So these are important aspects. Do we even have all analytical methods for detecting possible risks and possible materials or substances and so on? And this, of course, brings the next point, Ellie. That means it's very important that we do some testing. We have pilots when we are designing new plants, so that we can recognize and notice different problems and risks in advance, if possible. Well, then I have just a few slides left. I found this Foresight study on circular economy and its effects on occupational safety and health, and I thought it was quite interesting, and not only positive, but the study explores different ways how circular economy implementations could impact us, and what consequences this could have concerning occupational safety and health. And they produced 4 different scenarios focused on circular economy and its effects on occupational safety and health. And they were not very positive, most of them. Here are some of them. Well, we're looking at the Roaring 40s in 2040. Well, if we have the fully circular and inclusive model, where the products that sell best are those that have the entire environmental impact assessed, cradle to cradle, and everything is done in a social and environmental sustainable way. Then we have the next where we are going towards carbon neutrality, and but still it's a little bit hazardous that yes, we are working towards carbon neutral version of circular economy and avoiding carbon equivalent emissions. But as this kind of environmental viewpoint is the priority, the job quality and working conditions are not quite following, or not, at least not in every area. And I think this is something that we need to be aware of that that we need to keep the occupational health things aspects alongside all the time. Well, the third model is of staying afloat amid economic and environmental crisis. And well, it's not a very positive viewpoint to it. People want a job and getting along is important, and but more like the economic viewpoint and the environment and social aspects are less important. And then the fourth model was that also by 2040 there's Europe is divided into those who prosper and those who don't, and the environment is not doing that good, or is not really a priority. And circularity is only regional, and it's not integrated into the whole system. Then some implications in the waste sector in these same scenarios. And well, the first scenario where the cradle to cradle was the goal and the go-to version, and everything is fine and reuse works well, and all the environmental and safety considerations are dominating all kinds of decision making within the field. Then we have are reaching the second scenario is we are reaching carbon neutrality, but not in a very sustainable way. Of course, the carbon neutrality in Europe is important, and but other environmental well, this has been prioritized over everything else, and which makes job and working conditions more problematic. And then the staying afloat scenario, where really the environmental and it's not economically or environmentally sound, and well, doesn't sound good in any way. And then we have the model where Europe is divided into regional circularities, and the good environmental and circular economy aspects don't concern everybody. It's not a standard, but for few and a chosen and this doesn't sound very good. And then what implications it has on the waste sector? Well, in the first, you of course were both the social and the environmental aspects are well taken care of. Waste, the waste industry and circular economy processes are automated, and all the hazardous steps can be, the risks can be reduced in them as very effectively. And we are taking into consideration also occupational health, safety and health aspects, and are well trained in that sense. And well, the second scenario, it was the one with carbon neutral aspects, but not in a very sustainable way, in a hazardous way. And as the carbon neutrality is the most important aspect, all the hazardous aspects are and risks are forgotten, and this way the occupational safety and health is not integrated in the everyday work. And then the one where neither the red one, where neither economic or environmental aspects were met, well, it sounds quite scary for the waste sector and circular economy. Safety is not important in the workplace, since it's more important to just be able to, or have time to treat the waste materials, and the waste volumes have become more complex and more difficult to treat. And the last scenario where we have this divided Europe concerning circular economy, much of the waste treatment is outsourced, and especially if it's outsourced to less privileged regions, the know-how on how to treat the waste materials is not there, and this way also occupational safety and health is at risk. So I think these are actually only the first one, the green scenario is positive, and I think all of these other scenarios are quite scary, and I hope we can work through this and realize that we need to do things in a smart and safe manner. So I think this was my well, here the key messages was that of course we need to cooperate and be aware of what we are doing, and also be aware of the occupational safety and health aspects of what we are doing in our materials processing. So, thank you.